So if I take a truth table, from the truth table, if I am writing an algebraic expression, then always it will be in its canonical form, right? But if I take a standard expression, I cannot write the M notation to these standard expressions. Why? Because my M notations will be always based on my min terms or max terms. My min term or max term can only be converted to the M notation, right? If I am having just a product term or a sum term, then I cannot write the M notation to it. So what is that I have to do? Suppose if I am having a standard function with me, then I should convert it into a canonical form first, and then I should write the M notations for it, right? So now let us take one example and do that. So let me take an example. My function of a comma b comma c is equal to a bar b into a bar b plus b a plus c. Okay. So let me take an expression. So I have taken an expression over here. Now this expression, whatever I am having, how do I write it? So this can be written like this. This is a simplified expression. Let me write it in AB plus AC. This is my expression I have, right? Now, is this expression is in canonical form or non-standard form?
Standard form.
This is in its standard form, right? So now I should convert it into a canonical form. Why? Because I want to represent. What is your problem? Take note, your problem statement is to convert a given Boolean expression to its M notation. Convert the Boolean expression to its M notation, small m notation. Convert the given Boolean expression to its M notation. So as it is in the standard form, now I cannot convert it into M notation. What is that I should do? I should convert it into its canonical form, right? Now how do I convert it into a canonical form? So how do I convert it into a canonical form? I look into each expression. In this expression, which literal is missing, I should include that literal, right? So for that, I'll apply my distributive law. And what I'll say is, okay, in this particular expression, which variable is missing? C is missing, correct, right? So I'll write, can I write it like this? AB into 1 plus AB into 1 plus AC into 1. My expression will not change, right? I'm just adding 1 to it, right? An identity element. So which will not change my expression. Now what I do, I convert this identity element into C plus C bar. It's all the same, no? C plus C bar is equal to 1, correct? So 1 I have written in the form of C plus C bar. Why C and why C only? Because that is the literal that has been missing in this particular product term, right? So I'll write it as C plus C bar plus, what should I write it here? Here also it is C plus C bar plus, what I should write here? It is B plus B bar, right? Observe the modification we did. I wrote 1 with it and that one is written in this form. So which literal is missing in that particular expression? Write that literal form. Okay. So now what happens here? Yeah.
Then in the second line, when we multiply B,
your voice is breaking.
In second.
So this is how I write my expression. Now what is my next step? So I'll apply the distributive law and it becomes A bar B into C plus A bar B C bar plus A B C plus A B C bar plus B C A. That is I'll write it as A B C plus A bar B C. Right? So now I have converted it into canonical form now because every product term is having all the literals, so it is having a min terms. But before writing my notation, let me see if there is any duplication of the variables. So A bar BC is here as well as A bar BC is here. So let me write it together into one expression. So this is A bar BC plus again A bar B C bar, it's only one. I'll write it as A bar B C bar plus ABC on both the sides. So I'll write it as ABC plus ABC bar. So my standard expression a bar b plus bc into b into a plus c is converted into a bar bc plus a bar bc bar plus abc plus abc bar, right? So this is my canonical expression. Now from this canonical expression I should write it into its m notation. How do I do that? A bar bc, what is this? This is nothing but 0 1 1 now. So it is nothing but 0 1 1, correct? A bar is 0, b and c are represented by 1, plus what is this? 0 1 0. What is this? 1 1 1. What is this? 1 1 0, correct? That is how I can represent it. So what happens now? It becomes m3 plus m2 plus m7 plus m6. So let me write it in an order. That means nothing but sigma m 2 comma 3 comma 6 comma 7. Right? So this is my m notation. So I converted a given Boolean expression to its corresponding m notation. Any doubts? Take down this expression and do it. Quickly do it for this expression. Convert the given Boolean expression to its m notation. Quickly do it. So what we have done here, I have taken the m notation, big M notation now. So I have considered the normal form or a standard form of my pause. So in that, again, this is not a max term. Why? Because my literals are missing. So I am taking it in the form of a whichever literal is missing. So I am adding an identity element over here, that is 0. So it will be x plus y plus 0 into x bar plus z bar plus 0 I have written. So it will be x plus y plus, now 0 can be replaced by the literal which is missing in this expression. So that is z into z bar. So I have here it is y into y bar. Then I convert it into its canonical form. Then I represent it in a big M notation, m0, m1, m6, m7. So sigma m0167 is the answer. Now find out the m notation for this particular expression.
It is sigma.
So what happens to my expression? It is nothing but m1 into m6, sorry, m5 into m0 into m3. So it is 0531, correct? So it can be written as pi m 0135. So my expression is 01 0135. Okay. Now I have an expression which is in pause form, right? If I want to convert it into a soft form, tell me what I'm supposed to do. I have an expression in pause form, correct? This is pause form. Now if I want a standard pause form, now if I want to convert it into a soft form, what I'm supposed to do? I want this expression to be converted to the soft form, sum of products form. What I am supposed to do? Can I apply De Morgan's theorem to this? See what happens? X plus y into x bar plus z bar whole bar. Alright? Then what happens? It will be x plus y plus x bar plus z bar whole bar. Right? Now again if I apply the theorem, becomes x bar into y bar plus x double bar into z double bar. So what happens to the expression? Expression becomes x bar y bar plus xz. Is it not a soft form now? This is soft form, correct? Following? Yes. What exactly we are doing? If I want to convert a pause form to a soft form, then I'll apply De Morgan's theorem. If I want to convert soft to pause, then what I'll do? Again, I'll apply De Morgan's theorem. So by application of a De Morgan's theorem, I can convert one form of a Boolean expression to the another form of a Boolean expression. So now you are having a soft form, and if you want to write it in a small m notation, how do I do that? Then convert this into canonical form and write the m notation, correct? So if you are given with an expression like this, if you are given with an expression as a pause form, and if you are asked to represent the following expression using a small m notation, represent the expression using a small m, not a big M. This generally directly leads to a big M notation, right? But what you are asked with? You are asked with converting it into a small m notation. Then how are you going to do that? So whatever a pause form you are having, first you need to convert it into a soft form, and then this soft expression what you are having, you convert it into its canonical form and then write it in the m notation. Is this clear? Okay, so how do I do it? X bar, y bar into z plus z bar plus xz into y plus y bar. This is what I am writing now. So this becomes x bar y bar z plus x bar y bar z bar plus xyz plus xy bar z. This is what is my expression is. So what it becomes? It is nothing but small m1 plus m0 plus m7 plus m5. So I can write it as sigma m 0, 1, 5, 7. Okay, tell me what was the expression you got in this big M? For the same problem, what was your big M? Pi M? What is the answer?
0167.
Huh?
Sigma m of 0167.
0167. Okay, let us see. So yes, please. X bar, X, Y bar, 1, 0. Okay. So this is how I will be converting my big M notation to the, from the pause form, I'll get it into a soft. Yes. So assignment for you is same thing, you do it for that expression. Y plus Z bar into X. Represent it in small m notation. Okay, your question is to represent the given Boolean expression in its small m notation. Okay, so that is the assignment. Now let us move on. Now, okay, so see how much I have to struggle. I need to take an expression, convert it into its, by applying the de Morgan theorem, convert it into soft form and then write it in the m notation. Instead of this, we can go with one more form also. Okay, so what is the, if I am representing my any expression in a big M notation, I can convert it directly using to the small m notation, or if I am writing something in a small m notation, I can directly convert it into a Boolean function. How do I do that? Let us see. Let us consider that I am representing the given expression f x comma y comma z with sigma m 0 comma 1 comma 3 comma 6. Okay, let us consider this is the m notation that's been given to you. Now, what is the question? Convert it into big M. Okay, convert it into a big M notation or convert it into its conjunctive canonical form. Okay, this is a disjunctive canonical form. No? Convert it into a conjunctive canonical form. Okay, now what I am supposed to do? See, I have sigma m, which I can write it as m of 0 plus m of 1 plus m of 3 plus m of 6. What is this? This is my function f. Right? Now what I do now? I take a complement for this function. So it becomes f bar. So how do I write the f bar? F bar is nothing but m0 plus m1 plus m3 plus m6 complement. Okay, so what's the complement of m0, m1, m3 and m6? I write the complement function. Okay, so what's the complement function? What do you mean by this expression? This expression says that my function f is having high output at the input combination 0, input combination 1, 3 and 6. Now, what do you mean by complement function? Complement function expects me where for what all the input combination you have got 0. Correct? F is saying me, is giving me an expression for which are all the input combination I got output as high. That inputs has been considered for F. Now I am saying that I want F of complement of F. What do you mean by complement of F? For which are all the input combination I got my output to be 0. That is called complement function, right? Okay, now for which are all the function I could have got 0. So whichever is missing here, that will be giving me 0 obviously now. So I consider that now. So it is m2 plus m5, so m4 plus m5 plus m7. So this is my complement function. Be careful here. What is that I am writing? F bar. What is F bar? Which is a complement of F. So for what all the output I got, what all the input combination I got output as high, that combinations I have written here. Now what I write in the complement function, for what are all the outputs my function for input combination, my function is 0. Those input combinations I have written here. Okay. Now I will take a complement again. F double bar. So that is nothing but m2 plus m4 plus m5 plus m7 whole bar. I took the complement one more time. So f double bar is nothing but f only, right? Now for this, I have put a complement to entire function with a complement. So I can apply De Morgan's theorem now. So what happens? It becomes m2 bar plus becomes into m4 bar into m5 bar into m7 bar. This is what will happen. Now we have for converting my cos to SOP also have applied De Morgan's. So De Morgan's is going to give me a complement function. So this is the relationship I have. Mi bar is nothing but mi. Mi bar is nothing but mi. By applying De Morgan's theorem. We have seen it in the previous example now. So now what I do? So my f is nothing but m2 into m4 into m5 into m7. So f can be written as 5m 2, 4, 5, 7. This is how I converted my sigma m to pi m. Is this clear? Any doubts? Similarly, if you are given it x, y, z. ym 1, 2, 5, 7. How do I do it now? So I have pi m. Let me write it as m1 into m2 into m5 into m7. So what's that? That is nothing but my function is. Now, what is f bar? F bar is whichever is missing here. So it is m0 into m3 into m4 into m6. Correct? So whichever are missing here, that I will write here. Okay? Then again I get a complement, double complement of my function is nothing but m0 into m3 into m4 into m6 whole bar. So this becomes f is equal to, so when I apply whole bar it becomes m0 bar plus m3 bar plus m4 bar plus m6 bar. Right? So now what happens to my function? It becomes m0 plus m3 plus m4 plus m6. So which is nothing but sigma m 0, 3, 4, 6. So this is how I convert pi m to sigma m. Any doubts? Any doubts?
No.
Okay, let's take an assignment. Convert. Yeah. So expression is 4 variable now 0, 4, 7, 9, 11, 12. Okay. Similarly convert to small m notation. Okay, these are the 2 assignments you are having. Before the next class, you are supposed to do these assignments.